Welcome to a video that's entitled Good Query Structure. Let's just start off with a challenge. I'm going to give you two lists of names on two sheets of paper. Just picture the two sheets of paper are just absolutely jammed with a list of names, annual salaries, the dates the person was hired, person's age, and the department they're in. And I'm going to ask you to do me a favor. I need you to compare the two lists and compile a list for me of all the names that appear on both of those lists. So I want the common names between the two lists, but only show me those common names that have annual salaries over $50,000 a year, but less than $95,000 a year, and only if that employee has been employed by our company for less than 7 years, but not more than 12 years. Now, how are you going to arrive at the results? Now, here's what's interesting. If I give those two pieces of paper, and I've done this before in live class demonstrations where you come up with one of these scenarios, you give like 3 people in the class these pieces of paper, give them 5 minutes or so, and then ask them to go up to the whiteboard and explain how would you go about getting that information for me. A lot of times you'll see 2, 3, or depending on how many people you use, 4 or 5 different methods of how people would merge that data or, strike out the people that don't belong there or whatever. So there's always a number of different ways to get there. Now, this is exactly what SQL Server does with each and every query you write. It looks at what you've asked for. It looks at the tables, the data structures, and it also looks at things like data distribution and density and so forth. But it decides what's the best way to get the result sets that you're looking for. Now, the way you write and structure your query code is going to make a significant difference in the time and resources that's required by SQL Server to produce the result set that you're looking for. But go back and think about it. The way I word the question when I gave you the 2 pieces of paper can also affect the way that you go about trying to get that data. So let's talk about some good basic query practices. Now, when we're talking about good query structure, there's also the visual aspects. There's indentation and whether or not you put your keywords in all caps and when you go to a new line and that sort of thing. And you'll always find opinions about that. Hopefully, your organization or your company that you work for will have some sort of standards document on how you guys do all that. And you should, conform to that. But let's talk about query best practices here. First of all, in a production environment, don't use select asterisk. Like you see, we do a lot of times in class. Now, in class, we do this because it's quick and you don't want to watch me fat finger the word last name 26,000 times in this course. So I'll use select asterisk from person, not person quite a bit. In a production environment, that's not a good idea because basically I'm telling SQL Server, I just pull every column. And it's a lot harder, just like it would be for you, for it to pull 12 columns when it could have just pulled 2. Also, avoid any unnecessary columns in the select list. If you don't need the column for the data that you're looking at, for the query that you're writing, don't put it in there. A lot of people, if you put city and state, they're going to include zip. If you don't need zip in the result set, leave it out. You are adding a workload onto your SQL Server. Avoid unnecessary tables when you're in your joins, when you're working with table joins. A lot of times in the process of trying to figure out which tables we need, we throw an extra 2 or 3 in there, and then in the process of testing, we find out, I actually don't need that particular table. Take it out. Because just like with the example of the 2 pieces of paper, it's one thing to say compare these 2 pieces of paper, but now there's 3 pieces of paper. It just got exponentially harder and more difficult and more time-consuming to compare across 3 pieces of paper or 3 sets of data than just 2. So watch that. Avoid using or if possible. Or basically means that you've got to look at every record in that table to make sure there's not another possibility. Same thing with your list. Avoid using the word not if possible in your queries. This is another reason, because you're going to have to do what's called a table scan. You're going to have to look at every line on the data set to make sure that that one does not belong. So be careful with that. Bottom line here with or and not, write your queries the way you should be living your life, and that's not negatively. Positively look for what you want and don't look for the things that you do not want. Use schema.table naming in your queries. And again, in some places, you'll see me shortcut that in the class. But in the real world, you want to put the schema and the table name because it does change some of the efficiencies in the background when SQL Server is working out permissions, access rights, and so forth on these tables. And always include a where clause if possible. There are situations out there where your queries will not require a where clause. They're rare. And if in doubt, put a where clause in. A where clause tells SQL Server, first of all, that it can use an index and it can know when to stop looking, and it can maybe skip 100,000 lines out of a 120,000 line table simply because the where clause in the index tells it, dude, you've reached the end of it. If it's not here, it's not going to be anywhere else, so you don't even have to look any further. So always include that where clause, and indexes are something you'll grab onto later on if you haven't already. So anyway, there's a lot of good things to know about good query structure. This is a good place to start, but be very careful because you can drastically change the amount of work SQL Server has to do to satisfy your request.